Most people don't realize how deeply chemistry influences climate change and why understanding the science behind it could be our greatest tool for action. Dr. Todd Whitcombe, a climate advocate and seasoned chemist, or kineticist if you want to get specific, shares how decades of writing, teaching, and research have shaped his view on the urgent need for change and why the next generation offers him hope. In this episode of the Climate Conversation, we discuss how climate change is not just a distant problem, but a web of chemical reactions that are occurring right now, like how the vibrations of carbon dioxide trap heat, or why wildfire smoke signals a bigger environmental shift. We also break down practical solutions that are well within our reach. In this episode of the Climate Conversation, we discuss how climate change is not just a distant problem, but a web of chemical reactions occurring right now, like how the vibrations of carbon dioxide trap heat, or why wildfire smoke signals bigger environmental shifts. We also break down practical solutions that are within our reach. The rates at which we emit CO2 are greater than most people realize, and the meaningful progress starts with informed individuals. His optimistic message: future depends on the next generation's willingness to act and their understanding of the chemistry that drives climate change. This episode was filmed and produced on the traditional territory of the Lheidli T'enneh, and as always, if you have any questions or comments, you can add them below or send me an email at joseph.shea@unbc.ca.
So my name is Dr. Todd Whitcombe. I've been in Prince George now for 31 years and about 102 days. I'm the chair of the Chemistry and Biochemistry Department at UNBC. And anything else you need to know? I have a PhD in chemistry. I've got my degrees from UVic. I'm an inorganic chemist by training.
Okay. That's 102 days. You know that to like...
Well, it came on August 1st.
Oh, you remember the exact date.
Which makes it a little easy to figure out just how long it's been.
That's some pretty quick math, though.
I'm not sure it's exactly 102. Somewhere in that ballpark.
You said it with authority, so I assumed that you knew.
Yeah, well, I do that a lot. It's a bad habit.
Okay. Rapid fire round. What is your go-to guitar right now? What would you pick up?
Good question. My go-to guitar right now, what I'm playing right now is my Gibson ES335.
Oh, it's a great guitar.
1972,
nice.
mint condition, actual 1972. It was produced on April 10th, 1972.
And that's the Sunburst one? It's got the...
No, I don't think you've seen it.
Oh.
Because I only got it this summer.
Okay.
And it cost a small fortune.
It's a new guitar I have to see. Okay. Name a complete album you've listened to recently.
Recently?
Sure. Most recently.
The most recent thing I was probably listening to, but I didn't get all the way through it, was the Beatles' Abbey Road.
Okay. I asked this question because I'm curious about people's listening habits.
My listening habits are very eclectic. I tend to listen to songs instead of bands, instead of albums.
Okay.
So, yeah.
All right. Favorite color?
Blue.
Coffee or tea?
Neither.
Okay. Water. Would you rather have a time machine or a magic wand?
Interesting question. What can I do with a magic wand?
It's up to you.
Because presumably if it's an all-powerful magic wand, I can go back in time, so I
machine.
don't need a time machine. So I'll go with the wand.
That's a good answer. I like that logical answer.
Maybe it's a Todd to break the logic of the question.
Cats or dogs, or neither?
Oh, both.
Both. Okay, that's good. Window seat or aisle seat on a plane?
Window.
Okay.
No question about it.
Okay, easy.
And the number you're thinking about is 7.
That wasn't a question, but I'm going to add it to
I
the
thought we were
list.
going into the Colbert questionnaire now.
No, I should actually do that. Okay, here's like a trivia tidbit question. Do you know what the greatest source of carbon emissions is right now in British Columbia?
Okay. The greatest source of carbon emissions in British Columbia are people.
Okay, true, but if you broke it down by sector. Within our control, I should say. The actual true answer is wildfires right now.
Yeah. You have a person breathes out about a ton of carbon dioxide a year. and there's 5.7 million people or 5.2 million people in this province. So you're putting out 5.2 billion tons of or kilograms of carbon dioxide a year from human emissions.
Right.
So
So we're getting into the climate change portion of the interview now. So that's it for the rapid fire questions.
didn't work so good, did they?
It's good.
But yes, I mean, wildfires are a huge emission. Industrially, we're still looking at things like cement plants and cows.
Yeah.
Greenhouse gases. I mean, there's 300 million cattle in North America. Each of them puts a kilogram of methane out a day.
Yeah. I think according to the province, our biggest, like sector-wise, is transportation still. Is the biggest one. But okay, so let's get to sort of the meat here of this conversation. We just talked about cows. That's not why I brought that up. But how does climate change intersect with your teaching or your research?
So, I mean, I teach 2 courses where specifically climate change comes up.
Yeah.
The first one was for years I taught a course on the chemistry of everyday life. And there was an actual explicit lecture in there on climate change and the science behind it, because there's a lot of misunderstanding about the science that results in the production of impacts on the atmosphere. The other course that I'm teaching is just my first year chemistry course, where I've actually used a lecture on climate change to sort of break the ground with the students at the beginning of the semester. Because one of the hardest things to get people to understand is that things like chemistry is not just a discipline that you study in school. It's what happens every day of your life, and everything you touch, everything you've ever eaten, everything you've ever breathed, everything you've ever done has involved chemical compounds. And understanding their impact and the impact they have throughout the environment. They are the web that holds the environment together. They are the thing that is the environment, are a series of chemical compounds. And getting students to understand that, so that when they go on and they start talking about relationships and interrelationships and trees talking to each other through pheromones, or that these are all part of a sort of chemical structure. So in one sense, carbon dioxide is a chemical compound. Methane is chemical compounds. Understanding the role that these play in generating and producing climate change is important.
Yeah.
And so I try to run that as a sort of theme through the first year chemistry courses.
I love that idea, that first year course. Is that still taught, or is that...
The everyday life?
Yeah.
I'm not teaching it this semester because I'm already teaching 2 other courses, and it was always sort of taught in overload.
Yeah.
But it's we can sit and have a conversation about that one sometime.
But I appreciate that, and I think part of the idea here in these conversations we're having is seeing where people bring it into their teaching material or their research, and not everyone researches climate change. But I know you have you've done lots of writing, like you put op-eds in the paper often on things like climate change. Was there a moment for you that sort of said this is a big deal, or is it sort of a gradual dawning?
It was long before I came here and long before I started writing. But yes, I've been writing about climate change for 31 years in the newspaper, so it's 31 years I've been having these conversations. And originally back in the 1994, 95 area, where we started doing them, started writing, they literally were science columns as opposed to op-eds.
Yeah.
They used to occur right beside the funny pages. It's a great place for them.
Because everyone goes to the comics, right?
Everybody reads the comics. And we're beside the colored comics on Saturdays. I started talking about global warming. And there was at least one strong anti-global warming individual in town who would dutifully write back. And the beauty of it is that the newspaper only lets them write one letter, and then they wouldn't carry his for another 6 weeks, whereas I could write 3 more columns in that time. But we used to write about climate change, write about global warming, shifted the language to climate change as we became a little bit more conscious about the fact that the climate was changing. But I also used to do a column on the CBC, and that was one where we also talked about climate change and tried to tell people about the basic science of what was going on. Just as you try to explain why the sky is blue, it's part of the sort of science that everybody should understand what the science actually has to say.
Yeah, because it's been a long studied phenomenon, really.
Mm-hmm.
Like this is.
If you go 1837.
Yeah. So one of the things I tell one of my first year classes, we talk about plate tectonics, and I'm like, this is a young theory compared to climate change.
Absolutely.
And so, like, how do people? You've been doing this for a long time now. So has the reception to this message changed through time, or is there always still this one person who's writing angry rebuttal letters about things?
I've even debated him on the local CFIS at one point. Had an interesting debate, and it was kind of Neil Godbout was moderating it.
Mm-hmm.
And at one point he says, so Todd, who doesn't have kids and doesn't have grandchildren, is worrying about the children of the future. And you, who have grandchildren, are not. Uh-huh. It was... Jonathan Swift said, you cannot reason a man out of a position he wasn't reasoned into. And so the hard part of this exercise is getting people at an early age to understand the science and understand the reasons so that they are reasoned into a position, and then it's hard to get them out of that position without having an equally a compelling, reasonable argument.
Yeah.
And so this is why I've been writing about climate change for 30 years and talking about it and doing presentations on it all this time. Was there a moment when you were doing your graduate degrees, like your master's, your PhD, where I
climate
didn't do
change?
a master's.
Oh, you just straight the PhD?
Yeah, one of those.
But when did you first encounter climate change? Do you remember? Like, what was the...
When did it first become something in my consciousness?
Yeah.
About 50 years ago.
50 years ago.
It's always... But I don't know if... You're too young to remember the 70s.
I was born in the 70s.
Yes, but you're too young to remember them.
I don't remember much about them.
There was the big fear at that point in time was a nuclear winter.
Yeah.
And what was really interesting, I mean, I actually was invited to go to the first meetings that formed the organization that eventually became Greenpeace. And we were very conscious of environmental issues, and we were worried about things like a nuclear winter. And what's really fascinating, and I haven't ever seen anybody expound this in the literature, but if you actually follow it, the rise of the testing of nuclear weapons in the late 40s, all the way through to 1972, I think was when they stopped the open-air testing. If you follow the trend, 3 to 4 years later, you'll see a cooling of the atmosphere, which once they stopped doing the nuclear testing, the atmosphere took off again. That's that cold period in there, which everybody points to and says, well, see, really, what happened, right? But yeah, I mean, on the other hand, from a scientific perspective, as you learn about this, Savante Arrhenius in 1894 said, you keep adding CO2 into the atmosphere, it's going to cause a problem. And he was verified in 1930s by a guy named Callender.
Yeah.
There's no question that you keep adding CO2 to the atmosphere, it is going to cause the planet to heat up.
It's one of the properties of the gas.
Yeah.
Yeah.
It's a chemical, physical property.
Yeah. And the earliest one, was that Eunice Foote? Who was the earliest?
There was a woman back then, but the one who got noted for it was actually Fourier.
Fourier, Joseph.
Fourier, who came up with the Fourier transform.
My namesake.
Was he your namesake?
Well, I'm Joseph.
But was that who you were named
No,
after?
that's not why I was named. Irish Catholic parents. That's why I was named Joseph. What do you see? I mean, what do you see as the biggest impacts of climate change, sort of in our local, regional setting? Because you've been here for 31 years too now, so that's long enough to sort of have that window
to see the climate change. And yes, you can point this out to people. And one of the fundamental problems is separating weather from climate.
Yep.
And I don't think I've lived long enough to really see changes in the climate. If I can make it a few more years, maybe. But, but you know, I mean, back in the 1990s, well, if you go back before the 1990s, when I came here, one of the big concerns were the mountain pine beetles and the fact that they were infesting the forests of the north and killing off all sorts of trees. And it was pointed out that the things that controlled the mountain pine beetles used to be a hard cold in November, it'd get down to minus 30, or a really, really hard cold in January when it gets down to minus 40. And neither of those two things were happening at that time, although there was one November where it was minus 28, and that was cold, a little snappy. But those things have sort of disappeared. We do see it. We've been down to sub-minus 40 temperatures twice in the last 5 years. Yeah. But we've also seen an increase in the temperatures. We've seen a change to a certain extent in the climate. We see when the green, there's still green leaves on trees out there right now, despite the fact that there's snow coming, and we haven't seen as much snowfall. We don't see it at the same timing that we used to. Yeah. It was in the 1990s, it was a rare Halloween. In fact, I don't remember Halloween where we didn't have snow on the ground. And now it's not so much anymore. So it's a very subtle change. Yeah. But a lot of it has to do with this place getting wetter.
Yeah, and I think I want to maybe hit on another thing that I think a lot of people that has really brought the issue home for people here anyways, is not maybe a direct impact, but it's a secondary impact, and that's smoke. Wildfire smoke in the summers.
Big time.
And so, I don't think we have long enough records to really look at how smoke has changed, but very clearly we're getting more smoky days in the summertime. Most summers now have these periods where it's like, don't go outside, don't do these things. And so, is that something that, you think is convincing to people? Or is it?
I'm not sure that people get the connection between smoke and climate change in quite the way that you and I would understand it. I think, and that's not meant to be derogatory towards people. It's just they're saying fire, smoke, problem. Yep. They're not saying what made it so the fire was able to happen, and what made the fire more violent than it would have been, say, 30 or 40 years ago. Yeah. Right? And I think those underlying things, the fact that we're having more fires and we're having them more frequently, and they're more robust. The fire up around Fort St. John is still going on, and it's been 3 years now, right? How those are things that are being driven by changing climate, which is facilitating the ability of fire to last longer periods. But the actual having the fire, because it's that sort of thing where you see a candle, you expect to see light, right? You don't sort of think about all the implications behind burning a candle. It's just light, bang, I can see. Yeah. Right? And this is, people see the fire produces smoke, that makes sense.
But it's the chemical reactions that are going into it. And
all sorts of stuff like that. And we won't talk about the creosols we're all sucking back. The different compounds that are being generated. Nitric oxide, which is just so good for you,
Yeah, those are tough, mentally to deal with, those smoke days. Like I know we had the one here, was it 2017 or 2018? Mm-hmm. Just the black skies.
Yep.
And
you can't golf in those days. We tried, honestly. It was, ball go 150 feet, you couldn't see it.
But it feels so apocalyptic, right? Like that's the word that comes to my mind when I experience those days and I remember those days. It did feel like this is crazy.
Yep.
But I guess, this idea of addressing climate change is such a big issue. There's so many different ways. There's personal accountability, there is corporate accountability, there's policies governments can enact. Where do you see, what's a low-hanging fruit that you see in terms of addressing climate change, whether it's an adaptation thing or a mitigation thing?
Well, we were talking earlier about the idea that transportation is still a huge driver. And we have the capacity, we have the capability, we have the knowledge, we have the skills to electrify our vehicles. One of the things that people don't know is that originally about half the cars were electric. If you go back before 1920, you'd find that there were a lot of electric vehicles on the road, and people were using them. And then somebody said, hey, we got all this oil, let's do it with something with it. And it's a lot easier. Charging wasn't, it wasn't like you could just plug it into your house. But we're now at a point, I just bought a plug-in hybrid. And at night I go home and plug it into my house. And sure, I'm going to be paying a little bit more for electricity, but in BC our electricity is pretty clean. It's not totally, but pretty clean.
Yeah.
So I'm not producing as many CO2 emissions by driving that vehicle.
Yeah.
That makes a lot of sense.
Yeah.
But I think the hardest thing about it all is taking that one step further and actually looking at what is essentially life cycle analysis.
Yeah.
Because, obviously there's energy that's been put in to build my car, to build the batteries. One of the things that I point out to students is that one of these things, how much water do you think is involved in making one of these?
I don't know how much water.
What would you guess?
Oh man, you're gonna challenge me here. I'm gonna go with 1,000 liters.
And you're absolutely right. 1 ton of water.
Yes.
To make one of these.
That was a lucky guess.
Oh, you knew it secretly deep down
I had
inside.
no idea. I actually thought it was gonna be a lot more than that.
No, it's about 1 ton of water to make one of these.
Really?
And if you think about it, that's an awful lot of water that you're using. But understanding that, every product you make, you don't even want to talk about the CO2 emissions to make one of these, right?
How many tons of CO2?
There's a huge amount of energy, there's a huge amount of consumption in making products that we take for granted. And the fun part is 1 million of these get thrown out every year in Canada.
That's not a fun fact.
So, a lot of CO2, a lot of water that just is tossed
Sent
away.
to the landfill.
I probably shouldn't throw my phone around.
It's a soft couch. It's okay. What are there places where you see actions happening and movement towards, a future economy or a future transportation system that is less polluting in terms of greenhouse gases? Or do you find hope anywhere?
Oh, I'm not sure I find it in the economy or the at a high level, but at a very simple level. Talk to kids. They understand it. They want to help. They really do. The next generation really has their eye on the prize here, and that gives me a great deal of hope. But the bigger issue is how do you convince people that running electric trains is a good idea? And more to the point, how do you convince people that running electric trains in the middle of Saskatchewan is a good idea? It's just like standing in the middle of Saskatchewan. There's a comedian who was talking about Spider-Man standing in the middle of Saskatchewan looking around going, okay.
These are useless.
What am I slinging off of, right? How do we? In Europe, there's a lot of electric rail, and it works beautifully. But then you have a population density and a physical density that allows you to do that. Japan, same thing. But could you imagine trying to run an electric train from here to Vancouver?
I can imagine it.
It's not something you could have electric wires all the way along doing.
Yeah.
So now you're really talking about battery technology and so on. And I mean, yeah, you could do it. I mean, I think having a high-speed rail between here and Vancouver would make life so much easier.
We do have those mountains. Those pesky mountains are in the way.
Yeah, drill a hole through them. Of course, that takes up carbon dioxide. You have to use dynamite and so on. Anyways.
So there's lots of issues. I want to come back a little bit to the teaching. I like this, this course that you sort of developed and taught, and that you specifically bring climate change into your lectures on chemistry.
Mm-hmm.
How do students respond to those lectures? Do you have any idea? Like, is there a resistance, or like, is it all, people like, yeah, this is fantastic?
To be honest, I would say right now that a lot of students have heard the messages. I'm not telling them anything they don't know. Well, with the exception maybe that I stand up there. You ever seen what carbon dioxide, the vibrational motions of carbon dioxide? You want to see the vibrational motions of carbon dioxide?
Yes.
Okay, so imagine this is a carbon atom. That's
Okay.
an oxygen. That's an oxygen.
Okay.
So carbon dioxide does one of three things. It either does this,
Okay.
or it does this, or it does this.
This is the movement of the atoms in the carbon
The
dioxide.
three carbon, the
Okay.
two carbons and carbon and two oxygens. That's what they do, and the net result is it's constantly
Okay.
doing this, right, and bouncing around like that. That's what carbon dioxide does. That's why it absorbs heat.
Oh.
Each one of these is they're what are called fundamental modes, and each one of these fundamental modes has an absorption in the infrared region in the spectrum. And so you have basically three absorptions that you have, or three fundamental modes that you have that absorb heat. And this is something that, doing a molecular dance is something most students have never done. But it's great,
I think it is great. I'm recalling I had a professor who taught meteorology when I was doing my PhD at UBC, and he taught sort of this course that grad students could take, and he did like the dance of the cyclone, which was amazing.
Well, I
And
also do a water dance too. Get
Well-
166 kids all doing this,
Fantastic. And maybe I think I'll kind of end it here on the teaching thing. But in terms of this course that we're building and this content here, some of it's going to be, spliced into the course materials. What would you want students taking this course to go away with? Like, what's a key message?
I think, one, that they are better educated about what is causing it, what is the science behind it, what are the things that we truly do know, what are the things that we think we know because the science would argue that, but we're going to have to wait 10 years to find out, right? And what are the things that people are saying that are completely absurd? There's one guy, Thomas Gold, who was arguing that we don't have to worry about CO2 because it's all going to get absorbed by the earth and changed into methane. And I'm pretty sure that's not going to happen. And certainly, I'm a kineticist by training. Kinetics worries about rates of reactions. And when you look at any equilibrium, anything that's balanced, it's balanced not because that's balanced. It's balanced because as it moves upwards, there's an equally responding force moving backwards. So things stay in balance because you've got a rate in one direction and a rate in the other direction. Excuse me. That's equalized.
Mm-hmm.
Right? Well, right now, the rate at which we're putting CO2 out has changed that balance.
Yeah.
And understanding that at a very fundamental level, that there's very fundamental sort of rate expressions that could tell you how you're altering that equilibrium. And that maybe we'll find a new equilibrium at some point. But until we find that new equilibrium, we're in a state of flux.
Yeah, I like that message. The whole rate question is something that has always stood out to me. It was an important message to try and get across. Like we don't think about it when we fill our cars, when we drive around. But I think it was Kate Marvel. She's a climate scientist with NASA, and she just said it is incredibly inefficient to use 115 million year old sunlight
to drive your vehicle.
And I was like, it really hits the message home. You're like, yeah, okay. So now we're talking about completely different timescales and rates of reaction.
But you asked me earlier what was the biggest polluter of generated carbon dioxide, and I said people.
Yeah.
And I said, we each produce about 1,000 kilograms a year, or 1,000 kilograms when we breathe out, and you can work it out and the like. There is a natural amount of CO2 that's being produced. Those trees out there produce CO2 as well as consuming it.
Yeah.
The environment has CO2 in it. Animals and all the living biota on it are producing it. And so there is a balance, and we were in balance. The amount we were producing and the amount we were consuming, or was being able to be sequestered through the oceans and other means, were balanced. And the problem is that we had this rate, so let's say there was 100 going this way and 100 going this way, and you're perfectly fine. And then along came people, and they started producing, and it's not just cars, but everything we do that adds to that has changed those two balances.
Yeah.
And so now we're not in equilibrium anymore.
Yeah. Yeah, and we started pulling it out of long-term storage and putting it into these short-term pools that can't absorb it quickly enough.
I don't know if you've ever studied the Hadrian Earth.
No.
The Earth has gone through 5 sort of distinctive phases in its existence. And at one point in time, our atmosphere was dominantly CO2. And guess who wasn't around at that time? The likes of you and I and any other eukaryotic organism.
Yeah. We wouldn't do well in that.
No.
I think I'm going to leave it there. I really appreciate the time you took to come in and talk to us.
My pleasure.
I did have one more question. Why did you answer the email, the call for the climate conversation?
Well, A, because you're a good person and I like talking to you.
That's nice to hear. Thanks.
And B, because I think it's really important to talk about climate change. And C, I think the course you're developing is going to be a really interesting course. And anything I can do to help you with it, I'm more than happy to do so.
That's awesome. Thanks, Todd. I appreciate the vote of confidence, and I appreciate you coming in to talk today.